All right. Good morning, everyone. Thank you all for being here. Uh, Morning sessions, not always easy to get to on time, but I'm very, very happy to see everyone who's here. This room will start filling up. We know this from experience. But great. We are actually on time, so we have a really interesting session planned. We have extremely distinguished guests who are going to be speaking. I'm very thankful they could make it here. Um, Here's what we're going to cover. Um, which Sorry, this agenda slide should come up. Yeah. Okay, so the first 5 minutes, I'm just going to do some context setting as well as introduce an upcoming AI for Power innovation platform that we're developing. Then we're going to welcome the speakers and have a 40-minute conversation before a Q&A. We can extend that to 40 to 45 minutes, depending on how it's going. I'm sure, there'll be so much to cover, but we'll cover the opportunity, the way to get from use cases to actual deployments, and then scaling across the global south, right? We have 5, maybe 10 minutes for the audience Q&A. So we'd love to kind of have you engage. Um, as I mentioned, a quick context setting. Okay. Yeah. So just a quick snapshot of our organization, the Climate Collective Foundation. I'm really thankful from the Climate Collective to the UNFCCC Global Innovation Hub for this partnership, for co-hosting this with us, and also with the team, Nitin, James, Manali. We're looking forward to doing a deeper partnership as we progress. Climate Collective is an ecosystem support organization in the climate tech startup space. Okay, 1 second. Oof. Go back. I'll do it. Why is this going back? Should go back. Yeah. All right. So this is an organization, the founding team, including me, we were project developers in the solar and wind space, built about 84 megawatts. It's a ninth year, 1,270 startups supported in 96 programs. It's the largest such platform in India and the global south. Uh, our model is across acceleration, entrepreneurship development, industrial decarbonization, capital provision for startups, and convening the community. A key part of what we do is industrial decarb, and this is where this session has emerged from as we explore and do more in the AI climate tech space. Some are key partnerships. So we are a knowledge partner for you with the utilities for Net Zero Alliance, housed at IRENA, with Third Derivative, which is a joint venture between RMI and UIG Nexus, with Bloomberg NEF. We do the New Delhi Summit, GRP, Imperial, Waterfield, Grail, and some of our key funders are in that slide as well. This is a key one. It's an open invitation to all of you. We're doing the first Delhi Climate Innovation Week in February, 20th to 27th. 3 flagship events, 50 main events, about 400 events with partners. Great time to be in India. This is right after the India AI for Impact Summit, which is being held by the government of India. We're partnering with them on that, as well as doing some events as post to that during the week as well. Just a couple of minutes on how this panel emerged and work in the AI for Power space emerged. Electron Vibe is an open innovation platform that has been working with utilities since 2020. About 20 utilities have participated and 12 pilots have emerged. It's the only program in the global south that does this. And the theory of change is we get utilities to tell us their problem statements. We do a global call for application for startups to address those problem statements. That leads to pilots. That eventually leads to large deployments. Okay. And eventually, we have a pretty strong pilot conversion ratio of about 25% of the business cases that are developed, right? So the overall goal is for a decarbonized and a modernized grid. You'll see a lot of the key partners who work in the power sector are involved in Electron Vibe. You can access a lot of, so there's about 63 startups that are vetted and have worked with utilities, you can access that on our startup hub and some of the case studies that have demonstrated value for utilities as well on our website. Um, just the last minute on this platform that we're developing. It's called the AI for Power Innovation Platform, and this is emerged with the foundation of Electron Vibe. That's on top. We have already built this AI for Power Knowledge Hub, which is basically a set of co-located knowledge sharing events at COP, World Future Energy Summit, World Utilities Congress, New York Climate Week, London Climate Action Week, and then eventually a solutions platform, which will have a set of pre-vetted solutions and a data layer where we will be stewards of data from utilities on which innovators can build new AI solutions, right? So that's something we're very keen to collaborate on. We are building this out with a set of starting utilities and technology partners, and would love to chat about this more. With that, I'm very happy to welcome the panelists to the stage. If I can request Adam Elman, Director of Sustainability, EMEA at Google, Josh Parker, Head of Sustainability at NVIDIA, Manish Pant, EVP International Operations, Schneider Electric, and Natália, Oliveira, regionally Latin America for the Global Renewable Alliance. Thank you all for coming and welcome. Just leave this here. All right, thank you, everyone. Great. Without much ado, I would like to jump into the discussion. And please feel free to obviously talk about some of the key things that you're doing even beyond this, and what really drives you as individuals in the climate space, right? Manish, I'd like to start with you. So where do you see AI making the most immediate impact in power system optimization and operations? And we can talk about systems under stress or otherwise.
Sure. No, thank you very much. So first of all, it's great to be here and in this wonderful audience on a topic that is so important to the world, and especially the impact that it has on power systems, but not only. I would like to just set the context from perspective of Schneider Electric, which is the company that I represent. We are an energy technology company that is in the center of electrification, digitization, automation, which we feel is all required for the path of decarbonization, and especially as the world needs more energy for data centers, but not only. In the global south, it's a lot about the growth of population, the wealth creation, the infrastructure build, together with energy transition. I think all of them has to be addressed. So the challenges of global south are different from what we see elsewhere. And I think technologies exist today to move in this direction. Data centers for us is the largest segment, now represent about 24% of Schneider Electric last year. And we are present all over the world. We are able to bring the solution when Google is building a data center in the US or in Australia or in India or in Middle East. I think we are there. So this is what we bring. I think today, shifting gears with that. So, clearly energy is the base and of what, if there's no electricity, there is no AI. Sure. Let's put it. I think that, your Jensen Huang's latest GTC talks about, the base is the infrastructure and energy, and on top of or electricity, and then on top of that, everything else is built. So we are here to provide that. What we see is that in the global south, clearly the presence of renewables and 70% of the world renewable potential is in the global south. And therefore, for the new energy demands, we are able to move and leapfrog from the classical fuels to a decarbonized power system, or let's say at least on the supply side. And there's an example of Kenya. I know it's a small country, but in the last decade, moved from 38% to over 90% and renewable power without using, there was no fossil there. So clearly that it shows how you are able to leapfrog from, from a very low base to a very higher position. Now, this distributed generation, which is going to come in and can help our AI. It requires a lot of digitization because the only way you are able to integrate that into the grid,
True.
or for any assets where you want resilience is the key for data centers, you need a lot of digitization on the grid and digitization of the full power flow.
Sure.
Between the supply and the demand. And this is where I think today we have to go for. I think the level of digitization of the grid, which is going to feed, not just data centers, but be able to integrate all the renewable power, dispatch it, also have bidirectional or multi-directional flows. So there's no traditional grid. So this whole supply demand and the interface between supply and demand is what needs to happen.
Right.
There's a lot of work that has been done on the supply side.
Yep.
Now we still feel that the work on the demand side and connecting the supply to the demand, it needs to be digitized even more than what it is today. And that's exactly where Schneider Electric is. Now, AI has a role to play once you
Right.
have the data. So once you digitize, you have the data,
Yes.
then AI brings intelligence on top of it and creates a lot of efficiencies, and to say how we are able to perform better, do more efficiency, be able to do better asset utilization, be able to do
Right.
better predictive maintenance, use of digital twins. So all of that is unlocked, but the base is to create that digital layer where you are able to collect data, and then you can have AI on top. And this is the way I think what needs to be done before we are able to deploy even more AI.
Excellent. Thank you. You brought in important points. The need for baseload green power, but also flexibility, I think is important, is what you brought in. In India, we're very happy because Google has just announced a massive investment, probably the largest outside the US, perhaps. And you have a huge role to play on 24/7 CFE. CFE as in carbon-free energy, right? Which is critical for data center operations. So I'd like to hear from you, Adam. Is how is Google's shift to CFE, 24/7 CFE, and smarter electricity procurement strategy? How are you enabling that internally and for the ecosystem?
Thank you. Good morning, everyone. And thank you to Climate Collective for both hosting this important discussion, but also for your partnership, one of our key partners in the region. And we're really proud of the work we've done together. So absolutely, like many organizations here at COP, we've set ambitious, what we call moonshot goals. We're aiming to be net zero by 2030, but we also have this goal to run on 24/7 carbon-free energy. But I'll come back to that in a second, because I think, the first thing we look at is efficiency. How do we run our business as efficiently as possible? Now, that's good for the planet, but also it makes good business sense. If we're using less energy, less water, less cost. And we focus at every layer of the stack. We right down to the silicone. So we work closely with our friends at NVIDIA, but we also develop our own chipsets. Our latest tensor processing unit is 30 times more efficient than the first one we released in 2018. To put all of this in perspective, our data centers have 6 times as much compute power per unit of energy compared to 5 years ago. So we're very good at driving efficiency in terms of the infrastructure. We're also looking at the models themselves, and we use things like AI and a process called quantization to train a model now 39 times more efficient than it was previously. So again, really driving efficiency through the models. And then this is where we get onto the clean energy. So just to deep dive briefly into 24/7 carbon-free energy. So in 2017, so we've been buying clean energy for many years. We've done over 22 gigawatts of new capacity. Just last year, 8 gigawatts more than we've done in any previous year. And in 2017, we reached the point where we were buying on a global annual basis enough renewable electricity, clean electricity to match our global annual use. But that means you get to the end of the year and you say, how much did we use? And at some point, somewhere, did we buy enough clean energy? And we don't think that's good enough. And a lot of the science and the research and academic reports say that doesn't decarbonize grids everywhere. So 24/7 for us is we want to source our energy locally, so on the grids where we operate, and we want to match the generation on an hourly basis to when we're using it. So it's a much higher standard, but really means we're decarbonising grids where we are. And we're making good progress. We are now globally, last year we reported 66%. And as I say, we have a goal to get to 2030 to be 100%. And again, AI is helping us on our journey. So one solution is something called carbon intelligent load shifting, which uses AI to do two things. It basically says, what are the compute jobs we're going to need to run tomorrow?
Yep.
And what clean energy is going to be available around the grid at different times of the day. And it automatically shifts that around so we can make best use of the clean energy. Yeah. And of course, we're using that technology now to work with grid operators on demand response. So actually in Europe, in the energy crisis, grid operators were able to come to us and say, look, we're going to be constrained at this time. Can you reduce your usage to different places? And so again, the technology is really helping in this space. But I also think, again, some of this is just around sort of innovative commercial models as well. So, for example, in India, we've partnered with Adani Group and CleanMax, bringing 186 megawatts of new wind and solar. And again, that's required new commercial thinking to bring partners together and have blended types of renewables. So a lot of opportunity. We think AI is a real enabler in many different ways, from scientific breakthroughs to helping with science, education, but we need to do it responsibly. And, hopefully I'm showcased some of the ways in which we are thinking about this at Google.
Wow, excellent. So, I mean, the numbers are staggering, everything that Google and NVIDIA and everyone does. Load shifting is interesting. I remember reading an IEA report recently. Perhaps you were part of that. 0.5% of data center loads, if they shift, you don't need to add any more new capacity till 2030 in the US at least. So
yeah, I mean, it is an interesting, Mike, because as data centers, we're actually probably not the best. Our facilities have fairly constant loads, right. And so we're not like some operations where it's really easy to spin up and spin down. Yeah. But we are definitely part of, need to be part of that, and very much want to play our role and want to build that technology in AI to enable us and others, by the way, to be able to really participate.
Very nice, thank you. Natália, I'm going to come to you now. So at GRA, of course, you work globally, but I'd like to kind of zero in, particularly in emerging markets. What you're seeing from your vantage point across the value chain of renewables, where AI is playing a role. So we'd like to hear from you on that.
Okay. Good morning, everyone. Thanks, Nalin. And I'm so happy to be here representing GRA. And first, I'm so sorry because I'm almost with a bus, so I hope you can understand me well. GRA, as you know, represents 6 big renewables industries in the world: wind, solar, geothermal, green hydrogen, storage, and hydro. So we've been working since the COP of Dubai to help the world to reach the ambition of tripling renewables on 2030. And AI, it's pushing this, it's helping the world to reach this number. So I have some data here for you. Just the demand of data center electricity use reached 460 terawatts in 2024. And it represents a growth of 12% since 2017. And the perspective is to get until 945 terawatts by 2030. And yet, 60% of all energy used to supply data centers now are unsustainable. And the current AI use is with over 60%, as I said, of fossil fuels. And as you said, in the global south, we have the most renewable energy generation. For instance, here in Brazil, for example, we have 85% of clean energy being generated only on the northeast of Brazil. They generate 85% of all the renewables. So AI, what we are trying to discuss with governments is that the AI must be clean, and the cheapest energy is renewable. Right. So it's not only about ideology or just about the climate. It's also for companies. It's the most economic way
Sure.
to go. Yes.
Sure, sure.
So the AI boom is like reshaping the electricity demand, and the global data center electricity demand consumption, as I said, we reached 9045 terawatts in 2030. So if we get our targets to triple renewables until 2030 and put it to the data center so they can easily reach this number. So renewables are the fastest, the cheapest way to meet this demand. The digital solutions can help the renewables revolution. AI can help with the grid congestion. Asian DC demand will be 30% of the total national electricity demand by 2030, according to this Amber report. So AI can reduce grid and interconnection bottlenecks,
Right.
since this is the greatest problem faced in the global south now, because we have the curtailment, and we are throwing renewables really away, the renewables that have been generating here. And the AI also improves the renewable generation forecasting and security of supply, which is critical for markets with higher solar and wind variability, up to 30% of 20 and 30 data centers demand in many countries, in Asian countries, can be met by solar and without storage if forecasting and grid operation are effectively managed. Optimizing system also results in lower electricity prices. So as I said, the renewables are the cheapest
Yep.
and the fastest and the best way to bring more data centers, and the global south is bringing those investments, and because we have the most and powerful
Sure.
renewables.
Thank you. That's a nice overview of where we are. I think a good framework that we find useful is this three-step framework. So AI for energy, what can AI do in the energy space, on the power space? The energy for AI bit, which is making sure data centers are sustainably supplied with clean power. And then the greener AI is to make sure that, as Josh and I were discussing, the algorithms get more efficient over time. And that's what both of you have alluded to. Josh, coming to you, I'm sure another set of staggering numbers will emerge as we go through this. But how do you see advances in AI computing, edge to cloud, transforming the power system, energy systems, and also the integration of renewables? How are you seeing that?
Um, Absolutely transformative, and we're seeing more and more data that suggests that AI is really the best tool available to help with the energy transition globally. So it's perfect timing. AI is, of course, growing, and so it has a load that we need to manage. So we talk about that a lot, the footprint of AI, but it's also the solution to the problem that we're talking about as well. So a few things I'll get into on that, but just briefly at the outset, one thing to keep in mind, AI for power is one use case of AI. We're here at COP, we're talking about AI, or we're talking about climate generally. If you think about, and this is kind of my main message generally at COPs, is if you think about climate tech, if you think about climate change, if you think about all of the sustainability challenges that we're trying to solve here, which one of those challenges would not be solved better, faster, with more intelligence? And AI, if you use chatbots 6 months ago, they're different now. And chatbot is just one instantiation of AI, right? So overall message is, whatever work you're doing, whatever you're passionate about, whatever you care about, whether it's forests or biodiversity or emissions or climate change, the intelligence that AI can give you can help you with that. And so invitation is, come figure out what AI can do to help you, because this is the best resource any of us have. It's so democratizing, it's so easy to use. You don't need to be a coder. And at NVIDIA, we've got a lot of free resources to help startups, individuals, organizations, NGOs find ways to use AI to achieve the public good that they're trying to achieve. So that's my public service announcement at the outset.
Yeah.
For AI for power, really, really transformative. So if you think about what the challenges of grid modernization and adopting renewables onto the grid, it's really a complex system, right? Because more and more you have variable supply with renewables, and you also have more and more variable demand potentially when you have distributed energy systems with batteries and potential for demand response in a very distributed grid. The only way to manage that effectively is with a really, really smart digital infrastructure that allows you to balance the loads in a smart way to be more efficient with the resources that you already have. So the concept of virtual power plants, where you have an intelligent system that's helping you automate the flow of energy between endpoints, is really the best way to solve this, to make it more efficient and therefore more performative and with lower costs. And I'll give one example of something that we're doing to help achieve this. We have a partner in the United States, and they're reaching out broadly now. They're in the UK as well, called Emerald AI. And their technology allows you to take a data center and say, which by the way are grid assets, because they are firm power or firm demand generally, as Adam mentioned. So they can help offset some of the other ups and downs in power demand, because they're very reliable consumers of electricity. But they also can have some demand response. And this, so we've announced a 100 megawatt data center in the United States. We're partnering with Emerald AI to create demand response in the data center, so that when the grid is at peak load, we curtail the electricity consumption in the data center by 25% for dozens of hours per year. So very small fraction, like 1% of the year, we curtail the electricity consumption at the data center. And by doing so, we soak up a lot of the energy that's already being generated but not being used, because we have variable supply. And the goal here is to be able to say, okay, we've got all of this energy that's already being generated, we're not using because it's not matched where the load is in time and in location. But if we can be smart, as Adam mentioned with Google, in planning where we're going to have the loads, and think about time shifting, about geographically shifting, and also just curtailing the loads when we have that availability, we open up access to, in the United States, it's something like 100 gigawatts of energy that's unused right now. And we can soak up some of that energy and use it to create intelligence when it's available, and then go back and give electricity to the grid when it's at peak load. So these are some of the technologies that are possible, and AI really enables more efficient management of the grid. And at the same time, it creates more value in renewables, because the demand response makes the renewables relatively more valuable compared to firm power than it has been in the past.
Nice, excellent. And just for the audience to get a sense of, perhaps from either of you, what demand shifting might look like, perhaps non-critical tasks like a YouTube processing, but maybe just a quick, just 30-second of how you can actually shift some of these loads from the data center, just to guess it.
Yeah, I think there's two aspects to it very quickly. One is, what are jobs that can shift to a different time because they're non-critical. So you can imagine there's lots of stuff that happens in the background that can happen at different times. And then there's what is critical but can just happen in a different location. So it could be served out of a different place. So and then there's obviously things that can't shift. And so there are different variables. And again, this is where AI comes in, because it can figure out this stuff very quickly.
Nice. Great. Manish, I'm going to come back to you. So this is the next segment, and now we're going to go into specific deployments, perhaps pilots or even beyond pilots. Manish, from your perspective, can you share an example of where AI has improved grid performance, operational efficiency? It would be great if it's with a utility partner.
Sure. No, so thank you. I guess that just as a recap, I think what Josh and Alan mentioned, that it's great to hear that you start to look at how you are able to bring that excess capacity back to the grid, right? Either through processing or through shifting loads. And this is where it's very important for the grid to be ready to take it back and have that exchange. If we look at, and I will stay to the global south because I think that's what I know better, is that still there are a lot of areas where digitization is still not at the level that it should be, Okay. But having said that, a lot of cases where we have been working with utilities, particularly in terms of preparing the grid for this future,
Yes.
right? To integrate the renewables, but also to prepare for demand response either through storage or through use in homes and now even data centers. So I will call out a few of them. Southern Australia Power Networks, I think one of the utilities that probably if the next COP happens, that's where we are all going there. Quite advanced. We have been working with them. They have about 1 million data points that help optimize the usage of energy, and as well as it's not just usage, but also to make sure there's a resilience in the grid.
Right.
So the outages are drastically reduced. 1.2 million in savings on top of that, and reliability for over 1 million customers. You know, Australia is a small country, so clearly where they are able to take the AI concept to reality, and they start to work on it because they have all the data available to bring intelligence on top. Okay.
Right.
Then we have, take the case of India. You mentioned Tata Power earlier.
Yes.
I think they have been one of the first ones to do, as they bought some public utility networks and take them private. They first started with data, and they are using the ADMS from Schneider Electric to build the grid. At the same time, they also moved to using a lot of SF6 free, because in the grid today, all the gear is largely SF6. So we have now introduced SF6 free switch gear. So they start to adopt SF6 free. So both in terms of digital, but also ensuring that there's a lower carbon footprint of the assets that's there. Southern Egypt is another example where, in Cairo and New Cairo area, they have been working as they build the new cities, how they are able to build a digital grid right from start. There are over, I would say, 50 to 60 million people that are getting power from a digital grid. Here in Brazil, where we are, almost 60% of Brazil is an ADMS, which is a Schneider digital grid platform, ready to integrate renewables. I mean, we just heard how there's almost 80% digital capacity that is here. So a lot of cases where we see adoption of digitization of the grid, especially the smart grid. But I would also say that these are very early days in sense that the disparity, you won't say that it's the same everywhere. You could have pockets of a city, and here in Global South, you have cities with 20 million people. So you could have 1 million, which is a smart city with a smart grid, but then you have the other 18 million, which are still on the old grid. The good news is that there is a lot of abundance of power. Yep. And for data centers, if we say that if the passport to intelligence and the passport to getting data centers is energy, there's a lot of energy and potential, but also available right now. I think what we are seeing in the developed world, where to build new data centers, you have a waiting queue for a couple of years. It's not the same in the Global South. Sure. Because the power is available. Okay. All you need to do is also to invest in that, but also to build. The grids are ready to take it.
Grids are ready to take it. That's right. Josh, I want to come to you. We were just briefly chatting, and you mentioned a clear mission or clear target to constantly improve power efficiency, right, in your GPUs. So one, it'll be great to hear that a little bit about that. Also, how you work with potentially. I know you sell equipment, but you must also work with solution developers, system operators, perhaps, and how AI has supported that and your work in improving efficiency.
Sure. So the energy efficiency gains that we've seen in AI really dwarf anything that's happened, I think, in human history in terms of the scale of efficiency improvement over time. In the past decade, we've improved the efficiency of AI inference. So when you're actually engaging with the model by 100,000 times. And this is an analogy that we use sometimes to help make that clear what that means. If the fuel efficiency of vehicles had improved that much, we would be driving to the moon and back on a gallon of gas. So it's really hard to wrap your head around that type
yeah.
of energy efficiency gains. And we continue to see that with each generation of AI, new hardware, new software, new algorithms, and we're really innovating across the stack. So the cooling is much, much more energy efficient and water efficient than it used to be. In fact, by the way, we don't talk about water as much at the climate conferences, but the water requirements for cooling data centers have reduced by 300 times over the past year as we've transitioned from air cooling to direct-to-chip liquid cooling. Energy efficiency is really profound, and that's of course critical so that we can unlock the next level of AI. And our CEO has actually said that performance per watt is our metric of success at NVIDIA. So that's how we demonstrate that we're succeeding. That's how we demonstrate that there's more you can do with AI for the same envelope, the same footprint. So it's really critical to our success.
Very interesting. I think, and that's why I think some estimates, IE estimates, and I'm sure you do your own analysis in terms of where AI power consumption will be by 2030, 35. It's still in that 2 to 4% of global energy consumption.
So globally, yeah, it's still in the single digits for sure. You know, locally and in specific countries, it'll be higher, of course. So you do need to think about that.
Thanks, Josh.
I think it's a really important point because if you read the newspaper headlines, you might think that AI is sucking up the world's energy. And like last year, this is IEA's data. Last year, all data centers, of which AI is a fraction of what they do, used 1.5% of global electricity. And yes, it's expected to double over the next few years, but it's only a tenth of the growth. Much more of the growth is coming from transportation, industry, heating and cooling. So I think we're very focused on this because it's the bit we own, but actually it's a much bigger challenge across industries. And again, this is where AI can be a real enabler to enable everyone else.
Absolutely. And Adam, I'd like to continue with you. I know Tapestry has been a fairly well deployed platform from Google X. Just building on Tapestry and anything else, would you like to talk about how you've engaged with utilities, system operators to turn AI-enabled tools, perhaps in planning, etc., into real system improvements?
Yeah, let me give you two examples. So first of all, starting with Tapestry, we have a part of Google called the Moonshot Factory, Google X, and they have a solution called Tapestry, which is really designed to do grid scale optimization. We're partnering with, for example, PJM, which is the largest grid in the US. We're deploying it in the UK. But in fact, just last week, we announced a big partnership with the city of Rio to help them on their journey. But if you look at Chile, we've been working with Chile for quite a while. They are really looking to get to 100% renewables and are using Tapestry to do all of the scenario planning. So how they can manage all the variables, everything down to bringing on electric car charging to battery storage, etc. And that's really helping them make progress. Again, with Tapestry and Google DeepMind, another part of Google, we've developed an AI model to predict wind output for them, which is 15% more efficient than the most efficient model that was there before. And when you think about energy curtailment and all the challenges in deploying clean energy and variable energy, that's having a huge both sustainability benefit, but economic benefit as well. So again, it's one example of how AI is really helping in this transition. Another example, actually, because we talk a lot about, obviously, the need to bring on new renewables. What we know is actually another big challenge is actually the infrastructure to connect all of this and the permitting and connectivity. But there's a lot of infrastructure that exists out there today. So in the US, we're working with CTC Global on advanced conductors and helping them to deploy that, basically getting twice as much throughput on the existing infrastructure. So clearly much cheaper and quicker than the new, putting out new infrastructure. So lots more to be done, but actually lots of work that's happening at scale today. And I think that's almost to your point, it's like one of my sort of messages I push a lot at the COP and other events is this is not technology we have to wait for. There will be breakthroughs that come, but this is technology that exists today that is having an impact at scale today.
Amazing. Natália, if I can come to you, if you've seen case studies across, especially the global south, that have enabled faster renewable integration into the grid, it'll be great to hear from you.
Yes. The emerging markets in Latin, they can use renewables to capture investments and they have been using by offering reliable power. And I said Brazil, for example, that has 85% of green energy, renewables energy, and this only represents, for example, in wind energy, we can grow 10 times more than that we generate today. So
Okay.
This is where we can reach these investments and bring data centers to Brazil.
Right.
Not only Brazil. We just spoke about Chile. So what do we need to get those investments here and to develop more our renewables? We need regulation. We need grids and planning. We need bring stability to our systems. Because otherwise we won't be able to, as you were saying here, to bring stability to generate enough energy to the data centers. I brought here two examples on how this is effective in the global south. We have India, as you know better than I do, the time match clean energy for Mumbai data center, 100% renewables. And you also bring me, Manish, the example of Kenya. They also have 100% of clean energy for data centers as well. Here in Brazil, we have a great example in Port of Pecém in Ceará. We have this, they are generating over gigawatts of clean energy, renewables energy, mostly solar and wind for data centers. And we have many other planned for Bahia, for Rio Grande do Norte, for Piauí. The states are empowered to bring those developments here in Brazil because it's the only way to keep developing the renewables in the country, and also in Chile as well. And they are doing this very much. I've been there just 1 month ago, and we were discussing this, how the ambition of Chile to get until 2050, 100% clean energy with the use of AI, and how could they get this to bring stability to the system, not just their own system, because in Latin America, what we need to deploy, to keep deploying renewables, is regional integration, is to adjust policy procurement so that all the countries in the Latin America can have the same opportunities and bring their supply chain and share this supply chain, and also the flow of energy through countries.
Very nice. I think you brought important points, optimizing supply chains, for example. So we'll move on to the next section. I think we've heard. Yeah,
Can I make one more point on that? I think
please.
it's relevant to, so the renewable energy and the energy issue in the global south generally, this is, again, a really unique opportunity for the development of the global south, for the improvement of the infrastructure, and for just digitalization in the global south. And why is that? Number one, the companies that are building these data centers, like Google and others, have very strong commitments to use clean energy, carbon-free energy. As we've talked about, there's a lot of potential for clean energy in the global south in particular. We're also at a point where the cost really makes sense for renewables to be deployed, because they're generally cheaper if you're looking at a place where it's abundant. And then you have also with AI a demand that is good for the economy, but it's also flexible in terms of timing, and it's flexible geographically. So this is something that not a lot of people understand, but a large amount of AI workloads in AI factories, they don't need to be located anywhere in particular. You can train your AI models wherever you want and wherever there is energy. And especially because we're in this period where there's rapid expansion of AI, we're looking everywhere we can to find clean power. If we've got plentiful power, renewable energy, say, for example, in Brazil, this becomes a really, really good location for deploying AI factories and data centers, because that's the one thing that's really more constrained than anything else, more than chips, more than anything else. We need energy. And so this is a really good opportunity, again,
Yep.
because AI data centers can be located, a lot of them anyway, can be located wherever you have power
Wherever you have
for development and
Very interesting.
opportunity.
Can I add
You-
just one thing here? And it's also important for national security. If you have data centers based on your country and in your territory, it improves your national security as well.
Yeah. Fine, utilities should love data centers, right? Because they represent firm power, but also flexible power, right? It's great. Great. I mean, this has been extremely insightful for me. I'm sure for everyone here. We've heard about use cases that are actually happening. This is inevitable. It's going to get better. It's going to get more efficient. Now, I just want to come to the next stage, which is really scaling this across the system and across the globe. Manish, again, I'm going to come back to you on structural and regulatory enablers, which comes from overcoming barriers. Which utilities need to address to be able to deploy AI for power solutions at scale, right? So take whichever markets you're comfortable
Sure.
in.
And
Yeah.
I think we can stay very, still talk about the global south, but
Yeah.
to be, I mean, I come to that, but I was just reflecting on another point that was mentioned by Josh that clearly, when you look at the fossil fuels, you're dependent on 10, 15 countries for your energy needs. When you're looking at renewables, you are independent. I mean,
Everywhere.
so that energy independence happens when you're moving towards renewable, and cost is another issue.
Yes.
But in global south, we have the lowest cost of fossil, we have the lowest cost of
Mhm.
renewables as well, both. Now, coming to the question that you have, I think that few points that clearly come out, and it's a lot of conviction that needs to happen in terms of first doing everything digital by default. And still, right, there are, if all the utilities, and I repeat, it's a global south where, take the case of India, need to make sure that all expansion plans are based on digital. It means we
Right.
have to really in some cases, start from zero to digitize the grid to make sure that there's connectivity of
Yep.
all the substations, and the flow of energy is starting to become visible. This is first. Clearly, it is about financing and how we are able to put money towards building of the grids. There's a lot of money which is flowed on the supply side. Now it's the time of the grids and the demand side where we need to be working either on energy efficiency, but to do that, you need to strengthen the grid. So
Yes.
more financing is required for the grid. Sometimes it does not come out on the top.
Sure.
Okay. A third one I would say is more cybersecurity and interoperable standards.
Yes,
When you get digital, clearly there's we have seen some instances and needs to be really cyber secure, and interoperability
Yes.
is the other thing which is required as you build these software systems. Last but not the least, I think it's about partnerships. I hear some great examples from Google, from other organizations, that have been working on it, how we can work more closely together so that we are not replicating what we are doing. We are
Yes.
able to go faster through partnerships in scaling it.
No, thank you. That's very good. In fact, Adam, you mentioned this, but we were very happy to have Google as a partner for the first AI for Climate Tech Summit in India a month ago. And we were able to surface a lot of interesting use cases in AI across sectors, not just power, of course. And building on from what you mentioned about cybersecurity, interoperability, Adam, I'd like to come to you to just talk about some of the barriers around data availability, digital readiness, and trust, so that AI can actually become a true enabler for decarbonization.
Yeah, and the way we think about this, like, first of all, net zero is a global goal. We
Yes.
need to solve this everywhere around the world. And we've spoken about the opportunity that AI brings. Well, we want everyone to benefit from this opportunity. How do we, get everyone to, increase their quality of life, have the economic benefits and everything else that goes with it? So, we're very focused on that. I'm just going to rattle off, I'm conscious of time, a few examples. But for example, with regards to data, we have a solution called Solar API, basically gives solar developers individual rooftop information. We use our geospatial capabilities in AI. So rather than have to go out to property, they can see the roof pitch, size, amount of radiation, all the things they need to do to really accurately deploy rooftop solar. And we now cover 540 million buildings around the world. And the advancements in AI have recently allowed us to add extra 120 million buildings in 23 countries, much of that in the global south.
Wow.
So that's really providing the data to let others make more informed decisions and speed up deployment. Similarly, in Brazil, we're working with Map Biomass. Again, they're using our geospatial data to monitor deforestation. It's much quicker, far more accurate than they did before, and saves them a lot of money. We also want to show measurable impact as well. We have a solution called Project Greenlight, uses AI to optimize traffic junctions. So again, just bringing this local, the city of Rio, 2 other cities in Brazil are using this, 83 junctions. And we've just looking at last month, we reduced start-stop traffic by 9%. 15% fuel efficiency, and estimated 100 tons worth of GHG emissions saved. So again, you can see how that's having real benefit. But as mentioned before, this is much broader, and we need to think about sort of climate adaptation as well. We have an advanced AI hydrological model, which we combine with local data to predict riverine flooding up to 7 days in advance. It's highly accurate. We now cover over 100 countries around the world. And actually in places like Nigeria, Bangladesh, and parts of Brazil, aid agencies are so confident in the data now, they're able to either give preemptive grants to people, or local agencies are able to figure out where they should position their teams to take action when things do occur. So again, huge opportunity that can benefit the global north, but making sure that everyone really around the world can benefit wherever they are.
Amazing. If some of the entrepreneurs here were to want to use the Solar API or other APIs or other, I know there's the Insights Explorer, etc. So
you can Google it. You'll generally find it. But, I mean, we have certain solutions we give away for free. So Environmental Insights Explorer is a solution we give free to cities. Solar API is more of a commercial, opportunity. There's a whole raft of stuff. But yeah, I mean, Flood Hub is the solution I mentioned before. You can find that. We give it available to everyone. But then there are, for example, for governments and aid agencies, there's a different version with more detail going back, a lot of history, and allows them to input data and things like that. But yeah, you should be able to Google it.
Nice. Josh and Natália, I'm going to come to you to focus a little bit more on the global south now. Natália, first with you, policy levers or market mechanisms that could catalyze AI for renewable deployment. And you can focus on LATAM. That's large enough.
Yeah, sure. Digital investments is flowing where renewable energy is abundant, reliable, and scalable. So what we are missing, so what we need to do to move faster forward. So I have 3 things. First, modernization of grids and grids planning to accelerate the renewables approvals. Second, expanding access to corporate renewables to hyperscale the investments. And third, we need to focus and support storage and grid flexibilities, because the data centers need base load power, so they require firm, clean energy. Storage helps prevent instability, and renewables curtailment, as we were speaking right at the beginning. So how can we do this in the countries in the global south? Regulation. We need the countries to bring together their regulations and not flexible. I mean, I was thinking about flexibility, but it's not flexibility exactly. We need clean regulations so the companies can feel safe to invest in those countries. They have to be risk-free, not 100% risk-free, but it has to be clear so they can go there and be sure that their investments will bring results.
Right.
Yes, that's what I mean. So clean, as I say, clean AI, more cost competitive with renewables, 100% sure.
Very nice. Thank you. Josh, one of the most important questions for you now is what's needed actually, whether it's in better access to digital infra, compute, open innovation partnerships, to ensure that the global south can actually harness AI for systems transformation, right?
Yeah, and I'll just be brief. I'll make 2 points because we're getting close on time here. But the first one is, as Natália mentioned, you need an environment that's open for safe investment, right? So regulatory environment, infrastructure that allows us to build that out, because we're at this moment where there's so much economic value here and it's looking for a home.
Right,
These AI
right.
factories are looking for a place to be built. And so that's a big opportunity. And the second one is just about education, like making sure people understand what's available, what's accessible, what AI can help you with.
Yep.
And there are lots of, again, free resources that people can use to find that. And we're happy to connect people there.
Amazing. I'm gonna open up the floor for any questions, if any of you wanna ask. Yeah, please do introduce yourselves.
I'll ask my question from here. My name is Abhishek. I'm the founding partner of Indic Associates, which also runs a consumer initiative for new economy. And we are the founding members of Artificial Intelligence Knowledge Consortium in India, which is a group of organizations, think tanks, research organizations working on AI governance. And one of the problems, very significant problems to which policymakers have now started to focus on is what you said, Manish, interoperability. And interoperability of devices, of APIs, of clouds. I want to understand, in the context of a conversation, how big a challenge it is right now and how it is being navigated.
Question. Yeah. So I think, the way I can talk about how we are doing it, which is start to look at open systems. So if we have a couple of platforms, so EcoStructure, which is the digital platform for Schneider Electric, it's open, which means we are able to integrate other sensors and devices onto the platform. I'm based out of Singapore, where we have our headquarters, 20-year-old building, which is using 4,000 to 5,000 sensors. Probably 10% of them are from Schneider and rest from everyone else. And it's a platinum, net zero platinum. I mean, the Singapore government has its own classification, that building. We have Aveva software, which is helping create an end-to-end unified operating command center, where you are able to visualize, take, for example, an oil and gas platform or a hydrogen plant or a smart city. And all of that is completely agnostic, which means you could bring an ABB system, a Schneider system, a Honeywell system, but also water systems from others or other resources, and integrate into it. So clearly there's a big focus on that. Now, cybersecurity is a challenge that we need to overcome. So there are other challenges in it. So it starts with openness of organizations to be ready to work with others. Okay, knowing fully well, as you said, the customers would want that interoperability, and I think we truly believe in that. I can give you another example of software-defined automation, which is a new concept that is coming in, where we say we want to break the tyranny of the PLC. And we want, the IO systems, I mean, the software, the IOs and the compute, they could be all from different brands, but they would all work together. And we are one of the founding members of that. So I think that this is the way to go forward in the software world.
Um, okay. So I think we are at time. I'd really like to thank Adam, Josh, Natália, Manish for really enlightening me. I'm sure all of you as well. This is a growing space. It's already growing. We are at a time when things are already happening, and we just need a few levers to really accelerate it. The biggest companies in the world with the greatest resources ever in history are working on it. And it's a great time for entrepreneurs also to support or be part of that. So let's do it together. And thank you once again.
Thank you.